Consider this. Is the speed of light merely a figure? 299,792,458 meters per second. Incredibly swift. The swiftest phenomenon known to us. Very well. But here's the real question. Why does this limit exist? What prevents anything from exceeding it? Few have genuinely pondered this matter. They simply accept the fact. Einstein declared it so. Light speed represents the universe's ultimate velocity. That's simply the way things are. But this explanation falls short. It merely echoes familiar phrases. When you genuinely question why nothing surpasses light's velocity, when you examine what truly creates this barrier, you uncover something extraordinarily peculiar, something fundamentally divorced from daily observation that transforms your entire understanding of space and time itself. Light's velocity isn't merely rapid movement. It's not simply the ultimate speed. It represents the universe's very architecture. This constant is embedded within the structure of space and time so deeply that exceeding it becomes literally impossible to conceptualize. Allow me to demonstrate this concept. Clear's throat, we'll begin with something straightforward, universally understood. Objects descend. Release an object, and down it goes. 16 feet during that initial second, to be exact. Galileo established this measurement. Release a sphere, release a stone, release anything. Music, within 1 second it descends 16 feet. Now consider the moon. Our moon circles the Earth. It doesn't plummet downward. It remains elevated, orbiting, tracing a circular path. Yet pause. Is it actually falling? Consider this carefully. If our moon remained stationary in space, motionless, what would occur? It would descend toward Earth. Gravitational force would draw it inward. However, the moon maintains motion. It travels sideways, tangential to its orbital trajectory, and since it moves laterally, while gravity draws it downward, it continuously bypasses Earth. It descends toward our planet, but perpetually misses the target. An orbit is precisely that. Perpetual descent while traveling sideways sufficiently fast to keep missing. Now, here's Newton's brilliant realization. Our moon sits 240,000 miles from Earth's center. We stand on the surface 4,000 miles from that center. Therefore, the moon resides 60 times more distant than our position. Newton proposed, suppose gravity diminishes with distance. What if it adheres to an inverse square relationship? This means doubling your distance makes gravity 4 times weaker. Tripling it makes it 9 times weaker, the square of that distance. If this holds true, then at the moon's location, 60 times farther, gravity ought to be 60 squared times weaker. That calculates to 3,600 times weaker. On our planet, objects descend 16 feet in 1 second. If lunar gravity is 3,600 times diminished, then the moon ought to fall toward Earth by 16 feet divided by 3,600. Calculate this. 16 feet divided by 3,600. That yields approximately 1/12 of an inch per second squared. Hold on. Let me rephrase that. In 1 second's time, something at the moon's location ought to fall toward Earth by 1/12 of an inch times 3,600, since we're discussing the square of time within the formula. 1/12 of an inch multiplied by 3,600 equals 16 feet, precisely what we observe on Earth. Newton computed how far the moon ought to descend toward Earth in 1 second, if gravity follows an inverse square relationship, and it corresponded perfectly. The moon descends at exactly the rate Newton's principles predict. This discovery was monumental. This transcended mere theory. This constituted a prediction. Newton took one completely independent observation, the rate at which objects fall on Earth, and linked it to another entirely independent observation, the moon's orbital period and its distance from our planet. Two phenomena that appeared utterly unconnected suddenly became unified by one principle, the gravitational law. There was no reversing course. Furthermore, Newton proceeded. He computed what planetary orbital shapes ought to be if gravity adheres to an inverse square relationship, and he determined that it ought to be an ellipse. And what do you know? Planets do traverse elliptical paths. Kepler had previously measured this, but Kepler lacked the explanation. Newton provided it. He obtained 3 results for 2 calculations, as it were, and subsequently more pieces aligned. The tides. What causes tides? Because the moon exerts pull on the Earth. But consider this. If the moon simply pulls the Earth toward itself, there ought to be only one high tide daily, correct? The water bulge on the moon-facing side. But we experience 2 tides daily every 12 hours, approximately. What's the explanation? Some theorists believed the Earth was drawn away from the water. Others believed the water was drawn toward the moon. Both possessed partial truth, yet neither grasped it entirely. Newton understood what was genuinely occurring. The moon's force on the Earth and on the water remains identical at equal distance, but the water on the near side sits closer to the moon than the Earth does. Therefore it experiences greater pull, and the water on the distant side sits farther from the moon than the Earth does. Therefore it experiences lesser pull. So you obtain 2 bulges, one where the water is drawn more toward the moon, one where the water is left behind because the Earth is drawn more than that water. 2 tides daily. In reality, the Earth performs the same motion as the moon. It traverses a circle. The circle's center exists somewhere within the Earth. Both Earth and moon orbit their mutual center of mass. If you prefer, this water is expelled by centrifugal force more than the Earth is, and this water is attracted more than the Earth's average. Regardless, the tides were explained along with the fact that there were 2 daily. Numerous other phenomena became quite evident. Why does Earth appear round? Because everything experiences inward pull. Why isn't it perfectly spherical? Because it's rotating, so the exterior gets expelled slightly and it balances. Why the sun and moon are spherical, and so forth. As scientific progress advanced and measurements were conducted with increasing precision, the examinations of Newton's law became considerably more rigorous. The initial careful examinations involved Jupiter's moons. Through meticulous observations of their orbits over extended periods, one could verify very carefully that everything conformed to Newton's principles, and it proved not to be accurate. Jupiter's moons seemed to arrive sometimes 8 minutes ahead of schedule, and sometimes 8 minutes behind the schedule, where schedule represents the calculated values according to Newton's principles. 8 minutes. That's an enormous discrepancy. Something was amiss. But consider this. It was observed that they were ahead of schedule when Jupiter was near to Earth and behind schedule when Jupiter was distant. Rather peculiar circumstance. Mr. Rømer, having faith in the gravitational law, reached an intriguing conclusion. Light requires some time to travel from the moons to the Earth. And what we observe when we see the moons are not their current state, but their state sometime previously, the time required for the light to arrive here. When Jupiter is close to us, the light requires less time to arrive. When Jupiter is more distant, it requires longer. So he needed to adjust the observations for the temporal differences, and by the fact that they were this much too early or that much too late, he was capable of determining light's velocity. This was the initial demonstration that light did not propagate instantaneously. Consider what just occurred. We discovered light's speed not through direct light measurement, but through having faith in the gravitational law. When something failed to correspond, instead of discarding Newton's law, Rømer proposed, what if light requires time to travel? And he was correct. I present this particular matter for your attention because it demonstrates something. When a principle is correct, it can be employed to discover another one. By having faith in this principle, if something is incorrect, it suggests perhaps some other phenomenon. And if we had not understood the gravitational law, we would have required much longer to discover light's speed, because we would not have understood what to anticipate from Jupiter's satellites. This process has evolved into an avalanche of discoveries. Each new discovery provides the tools for considerably more discovery. And this beginning, it's the start of that avalanche which has continued now for 400 years in a continuous process. And we're still avalanching along at considerable speed at this time. But here's the matter. Once you determine light's speed, once you measure it, you begin noticing something extraordinarily peculiar. Light consistently travels at identical speed. Consistently. Regardless of who measures it, regardless of how rapidly you're moving. Let me make this tangible. You're standing motionless. You shine a flashlight. You measure the speed of the light emerging. You expect 299,792,458 meters per second. And that's what you obtain. Now suppose you're on a train moving at half-light speed. You shine the flashlight forward. You expect the light to travel at half-light speed plus light speed, equaling 1.5 times light speed. That seems logical, doesn't it? But that's not what occurs. You measure the light. It's still traveling at 299,792,458 meters per second, precisely the same speed. You say, very well, perhaps I measured incorrectly. So you get the train going even more rapidly, 90% light speed. You shine the flashlight forward again. You measure still 299,792,458 meters per second. You become frustrated. You get the train going at 99.9999% light speed. You shine the flashlight. You measure still the identical speed. Light speed does not combine. It doesn't merge with your speed. It's consistently the same regardless of how rapidly you're moving. This should shatter your understanding. This is not how velocities function in daily life. Velocities combine. If you're on a train traveling at 50 miles per hour and you walk forward at 3 miles per hour, you're traveling at 53 miles per hour relative to the ground. But light doesn't behave this way. Light consistently moves at identical speed relative to you, regardless of how rapidly you are moving. What's the reason? Einstein understood what was occurring, and it's so peculiar, so contrary to common understanding that even now, over a century afterward, people struggle to comprehend it. Time and space are not fixed entities. They're flexible. They bend and stretch to maintain light's speed constant. When you move more rapidly, time decelerates for you. Your clock literally ticks more slowly, and distances contract. The space before you gets compressed. These effects are genuine. They are not optical phenomena. They're not measurement mistakes. Time actually decelerates. Space actually contracts. And the amount they change is precisely the correct amount to make light's speed emerge identical for everyone. Let me repeat that. The universe adjusts time and space, bends them, stretches them, compresses them to ensure that light consistently travels at identical speed for everyone. Light's speed is not merely a velocity. It's a structural constant of the universe. Space and time are arranged in such a manner that this speed is identical for everyone. Now, here's where it becomes even more peculiar. If you attempt to accelerate something, anything to light speed, something extraordinarily strange occurs. The nearer you approach light speed, the more difficult it becomes to go more rapidly. It's not that you exhaust fuel. It's not that your engine isn't sufficiently powerful. It's that the object itself resists acceleration increasingly. We call this relativistic mass increase. As you go more rapidly, your inertia increases. It becomes increasingly difficult to push you more rapidly. And as you approach light speed, your inertia approaches infinity. To actually reach light speed, you would require infinite energy, which is impossible. So nothing with mass can ever reach light speed. Not because of some arbitrary regulation, not because of engineering limitations, but because space-time's structure itself prevents it. Light can travel at that speed because photons possess no mass. Zero. Massless particles can travel at light speed. In fact, they must. They have no alternative. They're consistently moving at that speed. But anything with mass, it can approach closely, very closely. 99.9999% of light speed, but never quite there. The universe won't permit you. Now, you might inquire, but why? Why is the universe configured this way? Why does a speed limit exist at all? And here's the answer that's going to frustrate you. There isn't a deeper explanation. Light speed isn't the speed limit imposed on the universe. It's a consequence of how the universe is structured. Space and time are not separate entities. They're woven together into space-time. And space-time has a geometry, a structure. And that structure has a built-in conversion factor between space and time. That conversion factor is light's speed. It's not that light is special. It's that space-time has a maximum rate at which cause and effect can propagate. Light happens to travel at that rate because light possesses no mass. But the rate itself is a property of space-time, not of light. If light didn't exist, the speed limit would still be present. It's a feature of the universe itself. Here's another way to consider it. In daily life, you think of space and time as separate entities. You move through space, and time passes. They're independent, but they're not. You're consistently moving through space-time at a constant rate. Consistently. But that motion is divided between space and time. If you're sitting motionless, all your motion is through time. You're moving into the future at maximum speed, 1 second per second. But if you begin moving through space, you must divert some of that motion away from time. You're now moving through space and time, which means you're moving through time more slowly. The more rapidly you move through space, the more slowly you move through time. And there's a maximum. If you could move through space at light speed, you would have zero motion remaining for time. Time would stop for you. This is why light doesn't experience time. From a photon's perspective, it's emitted and absorbed in the identical instant. No time passes. The universe is frozen. You can't go more rapidly than light because you can't have less than zero motion through time. That's the limit. That's the wall. And here's the beautiful part. This isn't merely theoretical. We've tested this repeatedly and repeatedly. Particles in accelerators get accelerated to 99.9999% light speed. And what do you know? The nearer they get, the more difficult it becomes to accelerate them further, precisely as predicted. GPS satellites must account for time dilation. They are moving rapidly and they're in a weaker gravitational field. So time passes differently for them than for us on the ground. If we didn't correct for this, GPS would be inaccurate by miles within a day. Muons created in the upper atmosphere by cosmic rays ought to decay before reaching the ground. Their lifetime is too brief, but they're moving close to light speed, so time decelerates for them. From their perspective, they live sufficiently long to reach the ground. From our perspective, they live longer because they're moving rapidly. Either way, more muons reach the ground than ought to, precisely as relativity predicts. It's not speculation. It's measured. Light speed, being a limit, is as thoroughly tested as anything in physics. So let's bring this all together. Clear's throat. Why is light speed the limit? Because spacetime is structured in a manner that has a maximum rate of cause and effect. That rate is light speed. Not because light is special, but because space-time itself possesses this built-in conversion factor between space and time. You can't go more rapidly because going more rapidly would require moving backwards in time, which doesn't make sense. You can't have negative time. You can't undo cause and effect. Light speed is the speed at which now propagates through the universe. It's the speed at which information can travel. It's the speed at which forces act. It's the maximum rate of change. And this process, this avalanche of discoveries began with Newton understanding gravity by observing the moon. Then Rømer understanding light speed by observing Jupiter's moons. Then Einstein realizing that light speed is constant and deriving relativity from that. Then thousands of experiments confirming it, each discovery building on the previous, each new insight opening doors to more insights. That's how science functions. That's the avalanche that's been occurring for 400 years. And we're still avalanching along at considerable speed at this time. Light's speed isn't merely a number, it's the key. It's the thing that unlocks how space and time function. It's the thing that shows us the universe is stranger and more beautiful than we ever imagined. And the fact that we can understand it, that we can measure it, test it, use it to make predictions, that's the beauty of physics. Not comfort, not simplicity. Truth.